Alright guys, this video is on the horizontal shift. Some people call it a phase shift. Okay, so now you have a value added or subtracted inside with the trig function. So that d value shifts the graph left or right d units. Think back to algebra 2. When you had something like this shifted your graph up 3 if it were minus 3, down 3. If you had something like this, that shifted your parabola to the right 3. Or if it were a plus 2, to the left 3. Or why am I saying 3? Sorry, 2. Okay? So same thing here. This is shifting our graph left or right that many units. Now, this is key right here. That d value should be our new starting value. Before, we always started our chart at 0. Okay? That value is going to be our new starting value. Okay? So let's take a look at an example here. So I have y equals sine and then the quantity x minus pi over 4. So I didn't have lots of stuff here. I didn't do a vertical shift or an amplitude or anything like that. I didn't mess with the period. This one's just basic. So our period's still 2 pi. There's no value right here in front of that x, okay? Okay, so our quarters are going to be the pi over 2 like they used to be because it's your period divided by 4. My amplitude's technically 1 if you want to write that down. You have no vertical shift if you want to write that down. Now, a minus pi over 4 means that we are going to the right, the opposite of what you would kind of think, pi over 4. So that's going to be our new starting value. So instead of 0, we're starting at pi over 4. Now we still count by our quarters. So if we add on pi over 2, we now are at 3 pi over 4. If I add on pi over 2, if you think about it, pi over 2 is technically 2 pi over 4 because we're in fourths here. So if you add 2 pi over 4, you get 3 pi over 4. Add 2, you get 5 pi over 4. Add 2 pi over 4, you get 7 pi over 4. And then 9 pi over 4. So now we're not necessarily ending at whatever our period is because we didn't start at 0. So keep that in mind here. Okay, now the values of sine are still that YOLO. Now, if you think about it, that is the value that comes out of the trig function, which is everything we have here. So these values are still 0, 1, 0, negative 1. There's nothing being done outside of that trig function. Okay, our domain is negative infinity to infinity, and our range is negative 1 to 1. Okay, so if we plot this now be very careful. If this is pi over 4 and this is pi over 4, then the next value in our table is here. You don't want to make this pi over 4 and then this be 3 pi over 4 because this gap is the same size as this one, and this is pi over 4 and this would be pi over 2. So be very, very careful with how you label these pieces here. I'll say that again just to be clear. Okay. Oops, that should be a 4. Okay, if this is pi over 4, you can't make this now 3 pi over 4 because this is from pi over 4 to 3 pi over 4 would be pi over 2. So you're not going to be scaled accurately if you do that. So be very, very careful at this point. So now pi over 4, we're at 0. Then we're at 1, 0, negative 1, 0. Make that curvy. Okay, so you can see that this took our sine graph, right, and it pushed it to the right pi over 4. We didn't really do anything else to it. Okay, let's look at another one. So this now has a lot more going on. Okay, so let's go through. Okay, my vertical shift is down 2 because of this negative 2. My amplitude is 5 because of this value right here. My horizontal shift is this. It's a minus pi over 2 inside, so that would be right pi over 2. Okay, and that's actually where this is going to start. I'm going to fill that in there right now. Okay, my period. Now, I do have a b value right here. Remember, your period is 2 pi over b. Okay, so 2 pi divided by that 3 is going to be 2 pi over 3. Now, your quarters are your period divided by 4. So if I take 2 pi over 3 divided by 4, that's really 2 pi over 12, which is pi over 6. So I'm counting by pi over 6. Now this is over 2. Okay, so if you think pi over 2 and 6 is 3 pi over 6. So now if I add pi over 6, I have 4 pi over 6, 5 pi over 6. I guess I lost the spot here. 6 pi over 6, which is pi, and 7 pi over 6. Okay, the values that go along with sine are 0, 1, 0, negative 1, 0. So now that 0 is what comes out of the trig function. So this whole part right here. So 0 times 5 and then minus 2. So this would be -2, -2, -2. If the trig function portion came out to 1 times 5 and then minus 2, that would be 3. If this came out to -1 times 5 minus 2, this would be -7. So now my domain still -infinity to infinity. My range, my lowest value is -7. My highest value is 3. Okay, so now to graph this, be very careful. I'm going to count by 6. Okay, so this is 1 pi over 6, 2, 3, 4, 5, 6, 7. Okay, so 2 pi over 6, what do I need here? 3 pi over 6, this would be pi over 2. 4 pi over 6, 5 pi over 6. Okay, so at pi over 2, I'm at -2. Okay, and then at 4 pi over 6, I'm up at 3. 5 pi over 6, I'm back at -2. At pi, I'm down at -7 and back at -2. Okay, so this took my sine function. It shifted that center line down 2. It stretched it vertically by the 5, that's the amplitude. It moved it right pi over 2, and then it also stretched it horizontally with that factor of 3. Actually, it didn't stretch it, it shrunk it, excuse me. Okay? All right, let's look at one more. Last one. Okay, so this one involves cosine. So it moved up 1 because of the +1. The amplitude is 3 because of that guy. My horizontal shift. Now this is a plus pi over 3, so that means it moved left pi over 3. Okay, the period. So this is that b value. So take 2 pi divided by that b value, so 2 pi over 3. This is actually the same as the last one. So if I take 2 pi over 3 divided by 4, I really get 2 pi over 12, which reduces to pi over 6. Now, if I went left pi over 3, instead of my starting value being 0, it would now be negative pi over 3. Now, we're adding on pi over 6. So negative pi over 3 and 6 is negative 2 pi over 6. So if I add 1 pi over 6, I'm now at negative 1 pi over 6. Add 1 pi over 6, I'm now at 0. Add 1 pi over 6, I'm now at 1 pi over 6. And add 1 pi over 6, I'm now at 2 pi over 6, which is pi over 3. The values of cosine are 1, 0, -1, 0, 1. Okay, so if the trig function, so this portion right here, okay, comes out to, ooh, I forgot to say something. Sorry, guys, back up 1 second. Notice from here to here, I factored out the 3. I just went off of this and completely forgot to mention that part. Okay, if there's a value in front of the x, like right inside of the parentheses with the x, you have to factor that out first. So if I need to factor out a 3, I'm essentially dividing everything inside by a 3. So what would be left is the x and then plus pi. So sorry, I forgot to mention that. I just looked straight to this line. Okay, so anytime you have a number right beside that x that's not out in front of the parentheses, you have to factor that so it's out front then. Sorry about that, guys. Okay, so the trig function, this whole trig function is coming out to 1 times 3 plus 1. So that would be 4. This one would be 4. If it comes out to 0, we just have 1. If it comes out to -1 times 3, and then that positive 1, we get a -2. Domain, -infinity to infinity. And range, the lowest is -2, the highest is 4. Okay, so let's be careful how we count here. I'm going to count by pi over 6. So this is -1 pi over 6. This is technically -2 pi over 6, which is that negative pi over 3. 0, pi over 6, pi over 3. Sorry, I didn't mean to space that out so much. Okay. Okay, so at negative pi over 3, I'm at 4. Then at 1, -2, 1, and 4. Connect that like a cosine graph, and it looks like so. Also, total side note, just to kind of help you think about this, I had a high school teacher who kind of compared sine to a snake graph and cosine to a cup graph, just so you can remember the two shapes of them and which one should look like which. So sine should look like a snake and cosine should look like a cup, or an upside down cup if it's reflected. Okay? And then the 4 problems that you have to complete are here. My key is below that as well. We will have office hours on Tuesday to do a couple problems together. I hope you guys are doing well.